Hey guys, I'm Nick and welcome back to the new tutorial. In this one we are creating this flip fluid driving rocks. And interesting fact about this one is that actually we will be mixing two forces from our fluids and from our RBD, so these are the exact collisions. And this tutorial was requested by Jonathan and it was actually made first by Sketchy Visuals. By the way, a few days we hopped on a call with this guy. He is super cool and he has a lot of very great tutorials for Cinema 4D, Octane and X particles. And also he sells a lot of these models, asset packs, all the project files. You can see that I actually watched a lot of his tutorials back when I was in Cinema 4D, so I definitely recommend you checking out his channel. This was the result he was creating, and we will be doing something similar. I'm not sure if his setup with X particles actually does the exact collisions, but anyhow, cheers to this man who did this kind of low effect for the rocks. All right, so let's break this down to a few parts. So first of all, we will need some points that will be our fluid, and these fluids we will displace them with a curl noise, which is pretty standard for all of these swirly motions, and then we will use the velocity from our fluid to actually drive our rocks. So let me start with let's build it from the kind of simplest way and then add a bit by bit additional stuff so this looks beautiful. We start of course by dropping GeoNode. In this GeoNode we will want to add a box, and this box I want to make it kind of vertical, so it will be 6.8 by 1 by 11.9 like this. So then we will need to add points from volume, and these will be basically our water points. And you can see right now we have probably too much of these points. I want to maybe set the point separation to 0.2 maybe, something like this. And also I want to make these smaller. We just need like 3 to 4 rows of these points, so there's no actual need to make like millions of them. Of course it depends of how you want this to be art directed, because you can go with a lot of small rocks and then you will get more of that fluid motion, like if it would be, I don't know, real lava or something. Or you can go with a bit lower count of rocks and then it will be like I did that. So it all depends on how you want this to stylize, and also fewer rocks, faster sims. Found it pretty win-win combo. So all right, I want to drop null here, call it out water, and then let's drop a dop network, and this dop network will be our fluid dop-net. So let's go inside and set up very basic fluid simulation. So flip object, this is the first thing that we need, and then we need flip solver. And basically that's it. In our flip object, I want to bind this particle separation to my points from volume point separation. So copy parameter, go to the fluid dop-net, click on this one, particle separation, and paste relative references. Also, this particle radius scale, we can bind that if we add a scale attribute here. Let's make it 1.2. And paste, copy parameter again, and let's go back to the fluid dop-net and particle radius scale, paste relative reference. So now basically any change that we do here in the points from volume for the point separation and particle radius scale, our dop-net knows exactly what to do. My input type should not be surface SOP, it should be this narrow band, and my SOP path should be out water. So right now you can see that we have something, and I actually I don't need any sort of these black sprites or something. So we can go to guides, particles. Let me make this bigger. Particle, we don't need sprites. We don't need even grains, I think. Yeah, I think we can go with particles. Or just to visualize it, maybe let's go with grains. But then again, I think that it will make, the viewport is not that responsive. So maybe let's go with particles. Yeah, this looks much better. So these are our particles. Color ramp, we can leave it as it is, because why not? We will see the dynamics. The higher the speed, you can see here visualization type is speed. The higher the speed, the whiter will be the certain particle. Also, for my physical, I wanna remove any bounce forward, and maybe we will add viscosity later. All right. I also want to close boundaries, and I think that's it for the initial flip fluid object, because right now you can see that we have this boundary which is really too big, and this and other properties we will be doing that in the flip solver node. So for the substeps I'm using the default, and for the particle motion there are a few things. So we want to uncheck reseed particles. We don't need reseeding here. And for the behavior, we maybe want to add ID attribute. It might help us. And then in the volume motion, there are a few things. So I don't want splashy flip fluid simulation. I want epic, which is swirly. And now I want to also decrease the box size, which should be 7.12 for Y, and for Z it should be 12 by 2. So yeah, something like this. Maybe you can decrease it a bit more, but we'll see. And yeah, of course, on Y we can go 1, but if you want more fluid to splash away and up, you're gonna go with like 2. And here I wanna, just for now, add gravity source, and let's just see what we have for now. So yeah, that's it. All the fluid just dropped, and yeah, pretty cool. So I think I want to go with this box size at 1. Yeah, like this. I think this should be great. And then of course we will need to add a pop wop, which will have our curl noise. So to the last input of our flip solver, we add pop wop. And this pop wop actually will drive our particles with curl noise, which is super cool. So there are a few things with the curl noise. If I just go and like drop the curl noise here, plug the position into position and noise to force, I don't think that it is the result that we are looking for, because eventually, I mean, it doesn't look that cool. Although, if you don't want to math with other properties, you can leave it as it is right now. I just want to make sure I add a bit offset by dividing time by a constant. So you can always plug the time to the, where it is, let me find it, time to offset, but then it's too slow, right? Like too slow, really. If I check, oh, nope, I don't need this one. Close paint tab. I mean, this works, but that's definitely too slow. So I want to divide my time and use actually divide constant, not divide. And then I can divide my time, I don't know, maybe by 10. And you can try different numbers for your divide constant, but I think this is what I want. And also I want to modify my curl noise. So I want to go with original Perlin noise instead of Perlin noise, and frequency for my X, I want to set it to be 0.5. For my Y, I want to set it to be 2. And for my Z, I want to set it to be 0.5. And my amplitude, I want to set it to be 3. And then I think all the values are default except this surface effect radius. I want to set it to be 0.2. And let's see what we have right now. So yeah, this is a really splashy curl noise. Maybe it's a bit an overkill for how splashy it actually is. So let me dial down the frequency, not the frequency, but amplitude to like maybe 2. Let's see how it goes. Yeah, this one is pretty cool. And if I up the frequency for X and Z, just want to check different options. Yeah, I think I want to go with this one actually at a 1, 2, and 1 in frequency, because I think it looks pretty cool. So, all right, our fluid dot network is done, and we can file cache it. But yeah, we will do that later. And from this one, let's create very basic RBD setup. So what I want to do is copy 2 points and copy spheres. The only thing I want to do here is just check that we are creating packed and instanced copies of the sphere. And let's save this project right now. All right, that's done. And let's copy our spheres to our points. And yeah, we can see that the scale, we can go a bit higher in scale, a bit lower actually, like this. And right now it's not an RBD simulation, right? It's just how these particles move. All right, so you can see blank spots here, but we will fix that later. So for the very basic RBD simulation, it would be drop the dot network here, attach your copy to points, and here I want to go with RBD backed object for this one, and rigid body solver here, and create active objects, first context geometry. Basically, yeah, for now, nothing happens because we wanna overwrite attributes, and one of them should be actually the B. And now if I play it, we will have the simulation on our DOP network. But this, of course, is nowhere near the result that we are looking for. So let me actually go another way. So after our fluid DOPNet, I'm gonna drop a null and call it out V, because from this fluid DOP network, we will need to read the velocity attribute, and this velocity attribute will be then passed to our rocks. And for our rocks, like sponsor of our rocks today is our friend and patron with the username Flamingo, and huge thanks to him for sharing his rock generator with me. And I've created a few rocks that are in the resources folder. Let me just copy the node from my first project here. Basically, yeah, I generated 5 times of rocks. Don't need these materials, but essentially they are looking something like this. And then I just use this transform and click move centroid to origin, so they all are zeroed out. And I think I applied, yeah, that's actually the same material to all of them. And yeah, so they look like this, like this, like this, and like this. They are remeshed, quite low poly, so will work great for the simulation. And now I want to add these rocks into my scattered points here. So I did that already a lot of times in my tutorials. So as usual, we drop the object merge, and we will need to add our out rocks here. Out rocks is basically a merge of all of these rocks, right? And then we want to drop a connectivity. This connectivity, for now, this attribute could be class, so no problem. And after that, we want to drop our attribute from pieces. And here the piece attribute should be class, because that's the thing that we have in our connectivity. And mode should be random. And we can plug the out water into the left input, which states point cloud, and our connectivity goes into the right input of the attribute from pieces, which states geometry library. And then we can drop copy to points. Don't forget to pack and instance them. And don't forget that here we also need this piece attribute. You can see here we basically have the connectivity piece attribute is class. So here we want to specify that same attribute class. And then this copy to points right input gets the attribute from pieces output, and connectivity goes into the left input of the copy to points. And now if we copy to points, we have all of our beautiful rocks. Of course, right now they are a bit big, so let's attach transform. And here I want to scale them actually smaller than they should be, I would say. So something like this, because I really don't need any of the intersections here. I really don't want them to be intersecting in any possible way. I think here they are not, and that is great. All right, so these are our rocks. And now I need something both for these points here, which are fluid DOPNet points, and these rocks. I need some attribute because I want to copy the velocity to my rocks without velocity. I want to copy the velocity, and right now I cannot do that. I didn't have any attribute to bind. So before our points from volume, or actually after our points from volume, we want to drop attribute triangle. And as usual, when we need to copy some attribute to another point, we need some static or constant attribute that we can bind to. So in my case, it will be ptid equals ptnum. So now I want to, of course, resimulate my fluid DOPNet like that. And then after my copy to points. Oh no, not the attribute blur, attribute copy. So this attribute copy, I want to copy the velocity from my DOP network, fluid DOP network, and match by attribute here. I should check that and write PTID. Attribute name should be V. Right now, you can see that we have our points with that attribute velocity. Of course, because we don't have any simulation, that velocity doesn't work, right? It doesn't change anything. But then now I can drop the DOP network. I can plug this attribute copy into my DOP network and here do the same thing. So RBD backed object and rigid body solver. So this goes into the output. Rigid body RBD backed object actually goes into the rigid body solver left input. Here it's our first context geometry and we are overriding the V because we will have it passing from the SOP. In my rigid body solver, I want to remove the sleeping time to 0. Yeah, and that's basically it here. You can up the substeps if you have any issues then, but I think overall that's pretty much it. For this one, just to make it faster for now, I want to go to the RBD packed object and hit insert velocity from point velocity. And for my bullet data, I just for now, I want to change the geometry representation to sphere. So now we are interpreting all of these rocks as tiny spheres. And it is just for now to show you how that collision works. Let's simulate a few frames, and yeah, basically that's how it looks right now. We don't have exact collisions, our rocks are not colliding, but still we have our velocity transferred to our rocks. That's good, that's great. And of course, now we will need to make these rocks look a lot better. So how we can do that is by scaling them up, all of them, to a certain point where we don't see any overlaps, and then also we will have a group of rocks that will be scaled a lot more, so these will be our those massive rocks. First of all, let's scale them all up while the simulation is going, because right now if I will scale them up, they will obviously just be intersecting. That's not the thing that we need. So we can drop the attribute wrangle, and in this attribute wrangle, let's call it scale all. So here is the thing. I want to start with their scale being 1, which is correct for now. And then I want to gradually scale them to some random value. I want to control the two states, this one with the scale being 1 and that scale where they are scaled up with a bit of randomness. I want to control that in the span of few frames. Actually, the more frames, the smoother your simulation will be looking, but I was going with like 15 frames for the whole scaling process. So I want to drop in this attribute wrangle, I want to write an attribute, or actually a variable called mix, and this I want to create a channel. So CHF stands for channel with a float value. I want to call it mix, and here I can click on this little create spare parameter for each unique control, each unique call of CH, which is channel. And if I click that, you can see that we have the channel, which is called mix. So here I can, for example, set it to be 0 at frame 1. I can hold Option or Alt or whatever it is and click, and there will be a keyframe. And then at frame, for example, here it is 15, I can set this to be 1, and then again hold Alt and click on mix. It will add another keyframe. And here I can specify that I want my scale, and its scale is actually an attribute of the packed primitive object that rigid body solver expects. So I want to go and make my scale, right now it's 1, cool, and I want to somehow make it like 2 at some point where the mix is 1. So we can do that using linear interpolation function. So here is the slurp, which performs linear interpolation between the values. So 2 values, it will gradually go from 1 to another value. So my first value is 1, and then I want to use my fit01, which takes the value in the range of 0, 1 and shifts it to the corresponding value in the new range, because I don't want my scale to become something between 0 and 1. I want my scale to be like the different numbers between the different range. So I want to grab the different number from my PTID, random number from PTID. This random number will be in the range of 0 to 1. This is what random function outputs. And then I want to shift it to be somewhere between 1.8 to 2.5. And the amount of mixing between 1 and the random number between 1.8 and 2.5 will be derived by this mix value. So right now, oh, of course, don't forget the another closing bracket here. So for now, I don't think that actually something will happen because the scale is not read by rigid body solver each frame. So in the RBD packed object, we want to add scale here in the override attributes. And right now, if I play it, you will see how they will expand and they probably will fly away. So yeah, we need a collider here. Let's create one. So we can drop box, this box for, if you use the numbers that I used for my particles, this box will be 7.6 by 3 and 12.4. And then I drop another box, which will be 7.3, or actually, yeah, this was 7.6, 3, 12, and 4. And this, another box will be 7.3, 3, and 12 by 1. And this one, we want to get it up to 0.2. And then we drop a Boolean. This Boolean requires our box 2 in the left input, box 3 into the geometry B, so right input. And yeah, we have some sort of a box collider for our geometry. Right now it's of course sitting too deep. If we check where our dopnet is, you can see, I can also just go wireframe ghost. You can see that it sits too deep. So we want to go and add a transform after the Boolean. And this one, I want to make it higher by something like this, 0.8. I think 0.8 will be good. Let's just simulate. Yeah, 0.8 definitely will be good. So after this null, just want to go with null and call it out box collider. And let's go to the dop network. And here I want to add static object. Then I want to add merge, and our rigid body solver goes into the merge static object. Static object should be on the left side of the merge. Don't forget that. And here obj pass, oh no, subpass actually, out box collider. We don't need to display this geometry. I want to just go to the smooth shaded how it was. And then I want to go with volume collisions, maybe enable this collision guide, and I want to go by size. I think going 0.1 might not be enough, maybe going 0.05 for this one. And I don't need bounce forward. For my friction, I can go a bit lower, like 0.5. And yeah, I think let's check what we have right now. Yeah, I don't think that my collider actually works. I think we should go with a volume sample here. Yeah, so we will need a VDB. Let's drop VDB from polygons after our transform. And this VDB from polygons, I want to reshape it. VDB reshape SDF and operation set to close. And then drop another null and name it out box VDB. So this looks pretty good. Maybe let's go 0.06 for our VDB from polygons voxel size. And let's go back to the dop network, set this mode to volume sample, division method by size, and proxy volume will be our outbox VDB. So let's try another take of these collisions. And here's the thing why this doesn't work. So of course in our bullet data, this should be concave because it's an open shape. And yeah, right now, if I update it, you can see that everything works. Just a few slight intersections, but that's not a big deal. So this might be actually too much in terms of how much we scale them. And yeah, this might be a bit back and forth till you find the values that work for you. For this one with a scale all, I maybe want to go with 1.2 and maybe 1.8 and just try with these values. With my dop network, I don't want to output my collider, so let's go and output only RBD packed object here in the object tab of the dop network. And let's play a few frames. Yeah, you see, scaling them adds a bit of more kind of like organic touch to them. They all right now are kind of with their own orientation. And still this, I think we are still using the sphere representation, right? So we can go in RBD packed object, and yeah, we are still at the sphere representation. So what if we update this to convex hull? I think then with the convex hull, we might need to up the scale also. But yeah, this takes a bit of time to simulate, but you instantly can see that right now we have much better collisions between all of them. They are actually colliding as rocks, not as spheres. And I think this is where we need to go with 1.8 and 2.3. I think that it was 2.3. Let me simulate these like 30 frames for now, and let's see how it looks. So this is what I'm talking about, and you can see now that they are all colliding perfectly. Look at this collision, for example, and right now they are all in a bit random scale. I want to make a few of them to be really big. So what we can do is we need to specify a group for our points, and this group will receive another linear interpolation between its scale and the new scale that will be much bigger. So I think we can even go here in after our attribute copy, we're going to specify a group which our primitives are packed primitives, so we can go with a point group. These primitives, these rocks are represented by the points, and I can go and keep by random chance, select this keep by random chance. So yeah, this is not the best representation of the keep in group by random chance. Yeah, I think that we still should go and add this group here. Yeah, this looks much better. So now I see that I just want like a few of these rocks to be super big, like maybe 3% or 4% of them. Maybe randomize the seed just a bit, maybe like that. Cool. And then after my scale all, I want to add another attribute wrangle, not the blur again, attribute wrangle. Yeah, cool. So this attribute wrangle will be scale big. And here I want to target only group 1, which should be named big rocks group or something, but yeah, for now it's just group 1. And so in this group, I want to add another scale, which will be 1 plus my another channel. Here I don't want to randomize them too much, although you can do the same thing here. You can just copy this, paste here. Maybe let's do this way, and then we can go with like 2.5 or I don't know 2.8 to 3, for example, or even I don't know 4 and maybe 3.2 and 4. Like this. So this scaling will be applied only to the this group, which is 5% of all the quantity of the rocks. Despite that we have just copy pasted things from scale all, here we need to click on this mix, and again we need to set the mix to be 0 at frame 1, and at the frame 15 we want it to be 1. All right, cool. Now let's simulate a few frames of the DOP network and see what we got. And here you can perfectly see that we have a few of these really big rocks like this and this, and maybe which one else, like this one and this one. So this looks pretty cool. But when we started this tutorial, right now I don't think that it's that necessary, but I want to show you one very interesting thing, because right now we are just copying the velocity to our points in the our rocks, and then we feed those rocks with the velocity, we feed them into our DOP network. What I want to show you is I want to just copy the DOP network. I want to uncheck these, and then I also want to copy the scale all and scale big, but I want to plug copy to points into my wrangle. I wanted to bypass this attribute copy and out v, and right now if I do so and plug the scale big 1 into my DOPNet, you will see that we are scaling them, but we don't have any of the velocity. Here you can see them scaling, but yeah, again, there is no velocity that will influence these rocks. For now, I want to bypass the scale big for this one, and let's go into the DOP network. So here's the thing, in my RBD pack object, I can uncheck overwrite V because we will be feeding V in this subsolver. We don't want inherit velocity from point velocity, and for the sake of speed, I want to set the collisions to be sphere. For this one, we will need subsolver. This subsolver goes into the post solve, and inside the subsolver, there's a cool little trick. So I wanna bring my velocity into the object merge, into the subsolver actually, and I will be using object merge. So we can select out V into the object merge here, and here I wanna bring this V into the subsolver with attribute copy. But the main thing is, of course, I want to match by PTID, and I want to get my V, but also I want to check the new name, which is new UV, and I want to plug this object merge into geometry to copy attributes from. And now you can see that we have V, but we also have new V here. And what I can do, like right now, we still don't have any velocity. We copied the velocity, but we changed the name, so DOP network doesn't know anything about it. So let me add gravity. For now, I want to also remove the visibility of the collision source. And now if I simulate, you can see they basically, they just fall down. Then they are scaled with something. Oh yeah, because they aren't represented by spheres, the scaling doesn't work properly. Let me also remove this one. So now, yeah, they all just fall down. That's it. So here in my subsolver, I can go and add another attribute wrangle. With this attribute wrangle, I can then also interpolate between velocities. So I can mix this velocity right now, which is basically the gravity, but I can add a little bit of the velocity from the fluid. And in this attribute wrangle, I want to create a few attributes. So my vector current V will be current V, and my vector new V will be actually this copied new V. And here in the attribute wrangle, we actually should add the DOP geometry to the first input and this new V into the second input of the DOP into the attribute wrangle actually. And here I want to go with 0.1 new V at ptnum. So I'm grabbing the new V attribute from this attribute copy, and now I can add linear interpolation. I can say that I want my V, I want it to be interpolation between current V and new V. And if I set it to be 1, it will just get the new V. So basically it will be that curl noise action here. But if I set it to be like 0.5, it will be a mix between the gravity, and you can see them going down, and also our curl noise. If I set it to be like 0.1, it will be much less curl noise than the gravity. I'm not sure if you will be even able to see the curl noise in action, but this mix actually gives a bit of more organic result that it is without mixing and just straight feeding the velocity into my rocks, the velocity from the fluid to the rocks. I'm not sure if we need to go with this for my setup because I already rendered it out. I already know all the parameters that I should use afterwards, and with this we can get into a bit of back and forth. So let's stick with this DOP network where we explicitly feed the velocity of our fluid into our rocks, but this I encourage you to experiment with this one, with actually mixing two values between each other. So basically right now we have the simulation working, we have all of our rocks, they respect the velocity that is fed from the fluid network, and I think right now we are ready to add our watch collider. This watch is actually something that I bought from TurboSquid, and I'm sorry, but I cannot share it with you here. This is against the licensing of stock models, and basically if I sell that model as a part of my tutorial, I'm cutting the sales of that guy who created this watch model. So you can check TurboSquid for anything where, I don't know, or Sketchfab, anything will work I will be just using this watch model that I have right now. I want to add another geometry. Let's call it watch, and I'll just copy paste a few nodes. Basically, there's this watch alembic file. I convert it to polygons, and then I reverse the normals and apply a few materials. Here are the 4 materials because there's this glass screen. Under that, we also have another like a watch face screen, and then there's this rubber material for the band. And then I scale it down. Why I'm scaling it is because here I have my rocks, and I want that watch to be sitting like just in the scale, in the level with my rocks. Of course, right now it's not. So let's press 4 for the right view. And in this transform, I need to get it up just a bit, just a touch, like this one. And maybe I need to scale it down a bit to 0.7, I think. Yep, like this. Or even to 0.6, 0.65. Let's go in the middle. And then, yeah, again, I want to make it sitting a bit higher, like this. So here you can experiment with a different position of the watch, like how deep it sits in these rocks. And yeah, right now we can see that we need to remove a few of our rocks. So also I want to remove them from the flip fluid, because if the velocity comes from the flip fluid, I want these fluid particles to also kind of collide around the watch. So in my points from volume, after that I will add a group, which is a group of points, but we definitely will need to introduce our watch, which is, we don't need to see it here, we just need to add object merge. And this watch, where it was, let me find this one. I want to plug that into the left input of right input of our group, which is bounding objects. And here I want to set keep in bounding regions with the bounding type of bounding object. So we basically can delete all of these points. So let's drop a delete and delete our group 2, which is points, delete selected. Cool, this looks good. I'm not really bothered by these little points here, but also we will need a collider. So let's from this object watch, I want to drop a null, which will be out watch collider, and of course I will need VDB from that. VDB from polygons. So VDB from polygons. Plug the watch in. Let's check. Yeah, we will need a bit more detail here. So 0.05 and VDB reshape SDF after the VDB from polygons operation to close like this, and add another null. Call it out watch VDB like this. Cool. So now we have our watch collider set up, and of course this first of all goes into the fluid dop network. Here, before or after my gravity, it doesn't matter actually. We drop the merge with the flip solver, and then static object, connect the static object into the merge, make sure it's on the left side. And for this, we are going to grab our out watch collider. And for the collisions, use volume collisions, mode, volume sample, division method by size, and proxy volume out watch VDB. So now I don't want to display the geometry, I just want to display the colliding geometry. And let's see what we get. Yep, they are colliding pretty nicely with our collider. So I think everything should be good. So once we have our fluid with the collider, of course I don't want to export the collider from the fluid dop network, so remove the Shift A sign from the object, and we just need the flip object here. All right, so before going into the dop network, I want to delete a few of these rocks because they will cause a few issues for us. So let's remove the scale big to dop network right now, and I want to add mask from geometry. So connect the scale big to the geometry attribute, and then I want to connect my out watch into the right input from the mask from geometry. So here, let's drop the color to better see our mask. So ramp from attribute is mask. So here's our mask. I want to delete everything where the mask is more than 0 actually. Delete points. So now you can see that it's obviously a too big amount of particles, amount of rocks being deleted. So we want to make our mask a little bit more narrow. So interpolation of the gradient for my mask, I want to set these both to the linear. And radius, I actually want to go with something like 0.1. Yeah, like that. And yeah, here we have better amount of rocks, better footprint of our watch actually, that then is used to delete the rocks. And of course, we will need to add the collider to our DOP network. So here's the same thing. Again, that same static object. This one though is not a concave, it's convex hull, and then I wanna add it here. Again, all the static objects should be on the left side. So in my static object number 2, I want to go with same thing as in the fluid, out watch collider for my subpass, and for my proxy volume, out watch VDB. Cool. So yeah, this looks pretty good to me. Let me ensure that we have our RBD packed object in convex hull representation, and let's simulate a few frames and see how it goes. And so here we have our rocks colliding with our geometry. Let me simulate like, I don't know, 90 frames. I'm too desperate to see the results, so there's only 70 frames here. So for this one, you can see that we have these blank spots. It collides nicely, works pretty well, but we have these blank spots. I don't like them that much, actually. So what we can do is, first of all, let's remove the color from my mask, because I wanna see my rocks. Cool. So I also wanna see how my grid collider, like the box collider, looks. So we are pretty close to the box collider. That's cool. I could add another row of my rocks to kind of add another amount of my rocks like this. So we now have four grids, but maybe let's go with the same size of my rocks, but then what I want to go with my box to be visible, and then maybe add another row by scaling my box up. So like this. I will need to update my fluid DOP network also, because right now you can see that our volume boundaries are not correct. So box center goes up like this. And I also want to move my watch. I want to move it up just a bit so it covers the rocks here. All right, now let's hide the watch and go back to the fluid DOPNet, and let's see how it looks right now. Yeah, I think this looks better because all the motion seems like it's happening more like on top of the fluid surface, but also maybe I want to manipulate my noise vectors here a bit. So let's go into my pop wop, and here I want to add vector to float, and because we will need to plug the vector into the force, I want to now float to vector. But here's the thing. So I want to plug the noise into the vector, and my X and Z values are the same. So I'm plugging them into my force. But for my Y, I want to revert it. So I want to multiply by -1 like this. And then I can plug this noise into the -1, and then the scaled value goes into the Y-axis of float to vec. And let me see how it looks right now. Yeah, I think this looks better. Let's stick with this one. And I also want to check if my mask from geometry deletes all the non-used rocks. I think we will be good with this one. And now let me simulate a few frames. Probably I will need to drop a file cache, and here I want to simulate 90 frames. And to make my file cache not that heavy, I want to go and add attribute delete before my file cache. Here I want to select delete non-selected because we just need our velocity and PTAD. And here I don't think that we have normals, so let's add normals before we file cache. And yeah, let's simulate 90 frames for now. And so now we have our rocks. They are pretty good in their motion. I think it looks really like swirly something. And then if we enable our watch here, now you can probably see that we have some rocks underneath the watch, but in general, I think it looks good with this secondary motion here. Not like a secondary motion, but more like a small swirly rocks going round the watch. And of course, now we can begin texturing this stuff. So you already seen that I have the same material in my rocks, but I will be using noise to add some bump maps to these rocks, and that's why I want the unique bump map on all of these rocks. And also pay attention that we are not unpacking these rocks. They are still packed primitives, and we will be rendering them as instances in Redshift. So now I want to add a color node to all of them, and I want a random color from attribute, and my attribute will be PTID. So now you can see all of them are absolutely random. So here I want to add an attribute which will be luminance, which will be @lum equals luminance from CD, just the color. And this I want to go and then colorize them again using another rem from attribute, and this one will be lum. So now you can see that all of them are pretty different in their luminance. And I can use this luminance attribute. I can call them like, I don't know, noise offset. Just want to copy that into this one without add. So this will be the offset of my noise, and this is how I will be sure that I am using different noise for each of these rocks. And then it's not necessary for now, but I was using retime for my simulation, and basically it was like 0.5 in speed, and I was going from, I think I still got like 30 to 60, and for this one I wanna, like, between 30 and 60 we have 30 frames. Oh, but actually it's not correct. So 30 to 60, and output range will be 1 to 60. Because 30 to 60 we have 30 frames, but if we divide the speed by 2, we will have like 2 times the amount of frames. And in these attributes I don't want to retime the UVs, of course. So let's go and add null and call it out rocks. Cool. So now it's the time to create some beautiful renders from this scene. Of course, I want to go and drop my camera. This camera should be, we can target here, but essentially it should be 1080 by 1920 with a focal length of 125, because I really don't want any of the distortion from the top side, like up and down look. So let me just quickly rotate it, something like this, I assume. So here we have -19, 0 and 0, and my translation should be 0 and 0 on Z, and we can go a bit higher in Y, maybe like this. And of course, I know about the lights. I actually use this RS light dome, which I'm basically using in all of my tutorials. I really like how it looks. So yeah, going with this brown photo studio, saturation set to 0, environment unchecked, and of course I need a grid behind my rocks, underneath the rocks. So it should be positioned a bit lower like this, or maybe even like this, I think. Yeah, and we can scale that grid by 3 or even 2 will be enough. And let's check what we see from our camera. And yeah, this looks good. Now let's set up our materials. Oh, but before that, let's maybe preview what we see here. So in my geometry, I want to go and probably name it correctly, right? So it will be rock sim. And in my rock sim, I want to go to the Redshift OBJ, and here I want to go in instancing, and I want to instance sub-level packed primitives. Also, I can go to the render and hit the mesh deformation blur from velocity attribute. This will help us with the motion blur. And let's save this project, and then new paint tab type, actually, Redshift render view. And I want to select my camera. Again, save this project just in case it crashes, and render it out. And here we have it, our beautiful rocks with our beautiful watch. All right, let me remove the watch for now, because we basically don't need it. I just want to work with the grid and our rocks. So for my material network, I create RS material and Redshift material here. I want to copy them, and this one will be rocks, this will be grid. So I want to go to the rock sim, render material. In my material network 1, I have my rocks, and then for the grid I do the same and select my grid. So my grid, actually we will be creating the dark version of the rocks for this one. So my grid will be black without any reflections like this. It's basically just a dark matter. Now let's focus on our rocks. So here I will need particle attribute lookup, or actually RS point attribute. Yeah, so this one, the attribute I want to get is luminance. Or no, actually we haven't named it, so it's noise offset. And this noise offset, I can plug that into diffuse color. Probably will need to refresh the render, but now you can see that they are all a bit of different color. This should go into the noise that we will be using to do basically everything with our rocks. So I'm using RS noise. This one don't need color here, but for my coordinates, and that's very, very important, we want to set the source to be vertex attribute, and our vertex attribute name should be UV. So for my noise, I want to set the complexity to be 7, amplitude gain to be 1.5, and my time should be user, so this user time. What I want to do now is I just want to expand these attributes of the RS noise, and my out color goes to the coordinate offset, and out color goes also to the time. Oh no, actually our scalar goes to the time. So now we will have different noise for each of our rocks. Then yeah, I want to use this rock for this noise actually for my rock roughness, for my rock bump map, for my rock diffuse, even diffuse. What I can do first of all is, of course, select RS bump map, plug the out color in the texture input, and then output to the overall bump input. This, of course, is too much. These rocks are not looking realistic to me, so I want to decrease the bump map scale to be 0.005 or something like this. This looks much better. And then I want to do RS color correction. And with this one, I can plug this into the diffuse color. And this color correction, I want to decrease the gamma, I want to decrease the contrast and level scale. So this should be roughly at these values. And now you can see that we have our rocks really, really glossy. So what I can do is get my noise from out color. I think without color correction, even without that, it should work, and plug this into the reflection roughness. So yeah, this looks pretty good to me. Now if we see the whole picture, yeah, I think this looks pretty good. I'm not sure if I should cover watch, but yeah, let's do that anyway. So for this watch, I have already set my materials, but the only thing they are not named correctly, I think. Let's go and make this redshift material 1, this redshift material 2, redshift material 3, redshift material 4. So now let's go and create redshift material 1, RS material, out color to the surface, and copy these 4 times. All right, so I know that my fourth material is basically glass, so let's add it here. And I want to decrease my IOR to 1.0.1. I think my redshift material 1 is just the band. Yeah, the band. So let's use preset plastic. It should be pretty dark. But we also have a texture with some of the kind of words that are engraved into the watch face. So RS texture, want to select this texture alpha 1, and then I will use that to mix between 2 materials. RS color layer is what we need, and this out color goes to base color. This another material goes to layer 1, and this goes to layer 1 mask, or texture sampler. And then this out color, we can plug that into the surface. All right, don't think that it works correctly though. Let's refresh the render just in case. Oh yeah, that's the issue is with the color layer, because we should go with material layer actually, because we are blending 2 materials, right? So base color, layer 1 color, and layer mask afterwards. And now if we get this out to the surface and refresh, yep, now we have the alpha here. All right, cool. Then I want to add a few sort of very, very small bump map noise, RS noise with the RS bump map to my black material here, color input texture here, overall bump input. I think I better will be with the RS max on noise. So connect it to the input texture. This one I wanna make it over with the input of UV and the overall scale of 0.005. And of course my bump map for now is too high. I wanna go with 0.002. Yep, like this. And I think due to that bump map, we somehow lost our, oh no, we haven't lost them. All good. And I just want to make sure my white material is pretty rough. Let me check what this material is. Oh, all right, so it's the watch face. So RS texture, connect that to the diffuse channel of our material, and I will be using this texture 0.2. Cool, sounds good. And I also know that I need this bumpy material for this little part here. So I can connect this exactly to here, and it works. And for my glass, I don't know why we have this thingy here. If I up the roughness, will it be still there? Oh, by the way, no, it won't be. Actually, I like this reflection a bit. But yeah, if I set roughness to be 0, but my IOR to be, oh no, this is not the thing that I need. Yeah, then probably I will need to just rotate my RS light dome slightly. Yep, like this, just 5 degrees. Or even we can go with 3. Yep, still works. Right, this looks cool, but it's missing something. And I think we can add a lot with post effects and redshift. I like them a lot. So I want to go with a bit more exposure, a bit more contrast. Then I want to go with photographic exposure too. In this case, yeah, I'm actually using that. A bit more f-stops, a bit more saturation, and I think we should go with YNet. Yeah, this looks better. So yeah, I think that's it. Again, as I said, feel free to experiment with, first of all, velocity blending in the dot network, in the RBD dot network. Experiment with the size of the rocks and their count, and also experiment placing the watch lower or higher. It will give you pretty different looks because I started with the watch being like very high, like too high, obviously. And then after a few iterations, I've got that result that you've seen in the beginning of this tutorial. But overall, that's it, guys. I hope you learned a few cool tricks today, and this tutorial comes handy for your personal and commercial projects. But I'll be back next week with a new tutorial. Bye!